Using the Ti-84 graphing calculator to multiply matrices. Southwestern College, Professor Maria Olivas. In this video, we will be using the Ti-84 plus CE graphing calculator to multiply matrices. Before we begin, let's recall an important fact about matrix multiplication. In matrix multiplication, if A is an m by n matrix and B is an n by p matrix, then AB will be of order m by p. So in this case, it is very important that we pay special attention to the order of matrices when multiplying. Here we have two matrices, matrix A and matrix B. Matrix A is of order 2 by 3. I will now list off the entries by row from left to right. In matrix A, in row 1, we have 3, 1, negative 1. In row 2, we have 2, 0, 3. Matrix B is a matrix of order 3 by 2. I will now list off the entries by row from left to right. In row 1 for matrix B, we have 1 and 6. Row 2 is 3 and negative 5. Row 3 is negative 2 and 4. To find the product of AB, it is important that the number of columns in matrix A is the same as the number of rows in matrix B. Here we can see that both matrix A and matrix B have the same number in terms of number of columns for matrix A and number of rows for matrix B. The product AB will be of order 2 by 2 because there are 2 rows in matrix A and there are 2 columns in matrix B. We are now ready to input our matrices into the graphing calculator. We're going to begin by pressing the second button. It's the blue button in the upper left-hand corner of your graphing calculator. And then we're going to press the x raised to the negative 1 button to access that matrix feature. We're going to scroll over 2 times to the right to get to Edit and press Enter. Once again, the default order of a matrix here is 1 by 1. We're going to change this matrix A to 2 by 3. And the entries for row 1 for matrix A were 3, 1, and negative 1. And then in row 2, we had 2, 0, and 3. Now we'll hit enter for that last entry and then go second and quit. We're going to go back to second matrix. We're going to scroll 2 times over to the right to get to edit, and we're going to go down 1 to be able to input a new matrix for matrix B. Press enter. Once again, the default order is 1 by 1, so we will change that to 3 by 2. In row 1 for matrix B, we had entries 1 and 6. Row 2 was 3 and negative 5. And row 3 was negative 2 and 4. Then once you've hit enter for that last entry, we can go second and quit. Now we're going to go second matrix, and we're going to hit enter on the number 1 for matrix A. Press the multiplication symbol, second matrix, and then scroll down to get to number 2 for matrix B and press enter. And now we're going to hit enter again, and we will get the matrix that is the product of AB. It is a 2 by 2 matrix. In row 1, from left to right, we have entries 8 and 9. In row 2, we have negative 4 and 24. Now, in order to show that matrix multiplication is not commutative, I'm now going to multiply B times A. So I'm going to switch the order to make sure I put matrix B first, and then times matrix A to show you that we will actually get a different matrix. Here, the product of BA is a 3 by 3 matrix. In row 1, from left to right, the entries are 15, 1, 17. Row 2, it's -1, 3, -18. And row 3, it's 2, -2, and 14. This shows that matrix multiplication is not commutative.